Hello, and thanks for using TickBoom, a free service that helps high school students with their math problems. In this video, I'll be answering question 7 from the 2020 Board of Studies Extension 2 trial paper. And this is just a continuation of a series where I'm working through all of the questions on this paper. So question 7 tells us that a particle is moving in simple harmonic motion according to the acceleration equation x double dot equals negative kx, where k is a known positive constant and x is the particle's displacement at time t. Given that the particle is initially at the origin and the information described above, which of the following cannot be determined? And our four options here are the period, the amplitude, the center of motion, or the initial acceleration. And I think this is probably the most straightforward question so far on this test, at least in terms of the fact that it really just requires a simple application of the concepts of this simple harmonic motion. So I'll have a crack. If you do find my explanation helpful, please be sure to give it a like. And if you're someone who wants to keep their finger on the pulse with the kinds of questions other students are struggling with, be sure to subscribe to my channel so that you can stay in the loop. So what I've done here is I've just written out our equation, our acceleration equation, and some of the facts we're told. So we're told that k is known, and we're told that when t is 0, x is 0, or in other words, we're at the origin initially. And then here's our four options. So I think, like with many multiple choice questions, I think we can get to the answer here just using a process of elimination. And in this case, because we're trying to find the option that cannot be determined, one way we can go about that is see what we can work out, because if we can work something out, we can just strike it out and see if we end up with only one option left. So I think what we can do to tackle this is to start by writing the general equation for simple harmonic motion, where we're thinking about it in terms of displacement. So that formula in general is x double dot is equal to negative n squared x minus c. And in this framework, what we're dealing with is we know that c is equal to the center of motion. And we also know that the period would be equal to 2 pi on n. So that's our kind of generic simple harmonic motion. Now, if we take a look at our equation for acceleration, what we're told, and I might just write this to be in this exact format, we're told we've got negative k just x by itself, but what I'll do is I'll write that as x minus 0 just to make it really clear how this all lines up, because what we can see is that k effectively matches up to n squared, and in our case 0 matches up to c. So right away we can conclude some things. We can say therefore the center of motion is equal to 0, because we've effectively got no center of motion here, so or it's just not there, it's 0. So what does that mean? That means I can strike out option C, because we can determine the center of motion, it's 0. We also know that if n squared equals k, then effectively n is equal to the square root of k. So therefore our period, instead of 2 pi on n, we could write 2 pi on root k. And remembering that k is known, that means we have determined our period. So that means option A can be determined, so therefore it's not what we're looking for. And now that we've got it down to these two options, the question becomes, can we work out one of these? And I think what we can use is this fact here, because initial acceleration essentially means t is equal to 0. So what we can say is when t is equal to 0, x is equal to 0, and when x is equal to 0, x double dot, the acceleration, is equal to negative k times 0, which is 0. So we can actually work out x double dot at t equals 0. So our initial acceleration can be determined. And this kind of makes sense because in general, something that we know is that acceleration is minimized, or in other words, it's 0, when the object goes through its center of motion. So because our center of motion we worked out is 0, and we're at that point 0 when t is equal to 0, it kind of makes sense that we're getting our acceleration also being at 0. So that means we can work out our initial acceleration, and therefore by the power of elimination, the process of elimination, the item that cannot be determined in this particular framework is the amplitude. And that's how I tackle that question. So hopefully you found that straightforward enough. I think really it was just a matter of knowing the generic, formula for simple harmonic motion where you're doing it in terms of displacement. And from there, it really just was just applying that in a fairly straightforward way just to kind of knock out the things that we could know. So hopefully that was helpful for you. And tick boom.